Happy Wednesday. Rainy one at that. That's nice. We're going to move on, right? We're going to look at finally polynomials. Polynomials. Right, polynomials have specific form. So quadratic is a special type of polynomial. Specifically, it's a degree 2 polynomial. Polynomials are of this form. Each of the AI is a real number. Right? Those are called the coefficients.
And then the n negative.
A n minus 1.
And then what's that, plus a sub 1?
And then a naught. N is the degree of F. Just be noted that N is a positive integer.
I'm sorry, well, that last bit, n is a element of,
It's a positive integer. Right, to be a polynomial, all of the powers have to be integer coefficient, have to be integers, positive integers specifically. A sub n is the leading coefficient. The entire a sub n x to the n is the leading term. And then a naught is the constant term, or just the constant. Put that. Oh, lovely. Crashed. Oh, nice.
I was gonna say, AU.
A naught to 0. Being able to identify the leading term and the constant term. Very important. All right, so what we're going to do for each of the following 6 is going to identify the degree, the leading coefficient, and the constant. What is the degree? Keep in mind, it does not have to be written in descending order of powers. All right, that just happens to be I think it's called the standard form. What does that make the leading coefficient?
-2.
-2. And our constant?
13.
Degree.
3.
Leading coefficient. And constant. What's the degree?
8.
Leading coefficient. And what's the constant? 16b to the fourth is our constant.
How can that be a constant if B is a variable?
But it's not a variable for the function.
Oh,
The function is only a function of a. Which means b, while unknown, is still a fixed value.
coefficient.
What about here? Degree. Leading coefficient. And our constant. Uh-oh. Degree.
2.
Leading coefficient. And then the constant. The degree. Leading coefficient. And our constant.
-4.
See that? Easy, isn't it?
So far.
Like I said, being able to pick out the leading coefficient and the constant is very important. And dealing with any kind of function, there are a few things that we always like to analyze. Intercepts, Right, where's it going to cross the y-axis? Where's it going to cross the x-axis? And its end behavior. How does it behave in the long run? We can easily find y-intercepts. Right. Let's plug in x equals 0. That's where it crosses the y-axis. Finding the x-intercepts. You have to set the function equal to 0 and solve for x, which is what we spend next week doing for polynomials.
Is that like algebra or is that something completely different?
You should have looked at quadratics in algebra and simple to factor polynomials in algebra. Right, the process that we're going to go over is for polynomials that you cannot easily factor. Right, there are two methods of factoring. There's factor by grouping, and then there's quadratic form. So if you have something like x to the fourth plus 6x squared minus 8, that's quadratic form that can be factored. But if I now throw in some odd powers in there, that's no longer quadratic form. It's a bit tougher to factor. So for the homework, the problems that were picked were either easily factorable or is already given to you factored. And it says find the x-intercepts. Once it's factored, you know how to do it. So next week, we're going to spend all of next week finding zeros of polynomials. It's not necessarily difficult. It's very tedious. It's not even really a lot of steps. It's mostly about luck. Because if you guess wrong, you could be at it for a while.
There's no way of knowing.
Correct. And if you're really unlucky, it's not even rational zeros, which means the process that we're going to go over is completely useless. At which point then I have to just go to a CAS and hope for the best. And that's just for polynomials. We study a bunch of different types of functions. You say that now. In my honest opinion, polynomials are actually the hardest zeros to find because of how tedious the process is. Trig functions, once you know trig, they're stupid simple to find, the zeros. Exponentials are stupid simple to find the zeros. Logarithmic, stupid simple to find the zeros. Rationals, well, they're basically polynomials, so. And then you have the hyperbolic functions, you have the spherical functions. You have the full function, the gamma function, oh, they're so fun. We're going to discuss end behavior. And so again, what do I mean by end behavior? Long run on both sides. So as x increases without bound in the negative direction and in the positive direction. The polynomials. It basically boils down to the same regards to the polynomial. I'm going to go back up to the generic polynomial. Let's say n is the 10th power. Now remember, end behavior, either very large x in the negative or very large x in the positive. Analysis is the same regardless. So I'm just going to stick with the positive. Pick a very large value of x. 100 trillion. $100 trillion to the 10th power versus 100 trillion to the 9th. 100 trillion to the 10th is a lot larger than 100 trillion to the 9th.
Yeah, 100 trillion times larger.
Which means that 100 trillion to the 9th doesn't really matter. Neither does to the 8th, the 7th, the 6th, or the 5th. Right? That 100 trillion to the 10th power dominates the entire function. So when you're looking at end behavior, just look at the leading term. That is how your function is going to behave at the end. So it behaves as a power function on the ends. You have two types of power functions, even and odd. Even obviously means that it's an even power. Odd is an odd power. Each of those two types can behave in one of two ways. So you have a total of 4 ways that a polynomial will behave. But given the leading term, you only actually have one of 2. I actually want to do AX to the n. If n is even, there are 2 ways that this graph could look. It'll either be something like that. Right, and the only difference is as n increases, it becomes more of a bowl. Bowl's the wrong word. This flattens out. Right, so it becomes flatter and the slopes become steeper.
X goes.
Not x, n.
As n increases.
For even. So this is more of like
Doesn't
a
that make it
x squared.
Doesn't that make it a skinnier parabola?
No. I know what
X to
you're.
the 4th is
I know what
skinnier
you're.
than X squared?
I know what you're trying to say. Skinnier is the wrong term.
Okay, vertical stretch.
Right. This flattens. Right. So you're eventually gonna have something that looks like this, sort of. Becomes more beaker-like as the power of n increases.
You're saying that, right? If A, all right, so A is just a coefficient.
Right.
All right, so let's just say it's 1 for now. All right. So you got your basic X, let's say n is 2. There's your classic parabola, your X squared. Now, if I think of X squared and I think of Y equals X to the 4th, I think of a much more vertically stretched and
Right, the sides
narrower.
become steeper.
Yeah,
And the, for lack of an inside starts to flatten out.
but there's only going to be a very small flat part, right? I'm trying to visualize this, I can't. So that's,
Now keep in mind the y-axis is changing to keep up with the increase. So again, it becomes more like a beaker, I guess. And then let's go backwards, forward. Thank you.
A little bit you scroll up all the way to the top, and it's like f of like x equals a n x to the power of n. That's a formula.
That's the form of a polynomial, yes. This is if a is greater than 0.
That's if it's greater than like a is greater than 0, and it's even, or
Both of these are n is even power. If a is less than 0, it just opens downwards. But nothing else changes. Now look what happens. For a being positive, left-hand side, the left n behavior, doesn't the function just keep increasing without bound? And same thing on the right. Right, so on either end, your function just increases without bound. So how this is represented f goes to infinity as x goes to minus infinity. So we're saying f is increasing without bound as x increases without bound in the negative direction. So that's the left-hand behavior. And then f increases without bound as x increases without bound. Or f tends to infinity as x goes to infinity. This is all even.
Can you, if it's, greater than zero is the top negative infinity. And then just the formulas down at the bottom.
This is left-hand behavior. This is right-hand behavior. All for a greater than 0.
Approaches infinity.
Right, on both the left and the right.
Right, yeah, it goes up on both sides. And then what's the second line?
That's indicating what side, what end, right? As x approaches
Yeah,
negative
no, I mean,
infinity,
the line underneath that.
this is the right hand. Right.
Oh, yeah, okay, sorry.
Well, a less than 0, it's f is decreasing without bound.
So stuff.
Taking you to a math lesson. And if a is less than 0, both ends, f just increase without bound in the negative direction. Right. We say increase without bound negatively. So that is if n is even. If n is odd, shape is something like this. Oh, I'm not going to just rotate this one because it's symmetrical about the origin. Bugger. I tried. I have to draw another one. That is so annoying. And again, all odd power functions except for first power, which is just a straight line, look like this. So, I mean, I guess I could argue that even x looks like this. This just is not pronounced at all, right? As the power increases, this bit in here just becomes more pronounced. So again, it's kind of like you're bending it. So as it decreases, it's going to become less pronounced, and I would argue that at 1, it just isn't there, so it's a straight line. Oh dear, why are you running so slow? There we go. But again, the basic shape doesn't change. For a greater than 0, look what happens. Decreases without bound on the left, right? And it's increasing without bound on the right. If a is less than 0, it's the opposite. Every polynomial will behave in one of these 4 ways on the ends. What it's doing in the middle, calculus for that. And even this I don't really like because this is technically calculus as well. The idea of end behavior is also calculus.
What's the difference between pre-calc and calculus? Like.
Precalc is essentially just algebra. It's just functions. You know, we're just studying the basic types of functions. It's really just an algebra course.
I learned about the derivative.
Really, it's all of calculus is just one thing, the limit.
Yeah. Your early emphasis on difference quotient. I mean, difference quotient is going to turn into limit at some point, isn't it?
No, limit of a difference quotient is a derivative.
I just know
It's still just a limit.
If you keep changing the delta x closer and closer to 0.
Right, but that's a limit. That is the limit.
All right, I mean, because when I see x plus delta x minus, I mean, f of x, it just, I don't know.
Yeah, that is a limit,
Yeah, okay.
which is a derivative. And so basically 3 semesters of calculus is just one thing, a limit. And all of its many uses. Right, so look at our polynomial. What you want to do is identify the leading term because that dictates how the function behaves at the ends, right? Again, that leading term is the dominant term. So what's the leading term?
2x cubed.
Now it's just a matter of matching this to one of the 4 graphs above. What's even? Why do we care about 2 being even?
What's the leading term? How about 3?
3 is the exponent.
Yeah.
So it's an odd degree.
So it's gonna be one of these two.
Is A 2?
Is it?
I think it is.
Just think, well, you know.
Well. Yeah, yeah, A, okay, so A is 2, so A is positive.
Which means it's this graph. This is the behavior.
So what's 2A?
2 is A, yes. And with enough repetition of this, you'll have those 4 cases memorized. You'll be able to look at every polynomial and immediately know the end behavior. Shouldn't take you but 5 seconds once you get really, really good at this. But again, it requires repetition. Until you're dreaming about it.
Then the exponent is like, that's what you do to determine whether it's an even or odd.
You look at the exponent, yes.
And the 2 is A, and then the.
You look at the leading coefficient, positive or negative. It'll never be 0, by the way. But then it wouldn't be the leading term anymore. See, it's easy, isn't it? That's not good. Don't say ow.
Oh, it's not just, man, I slept wrong last night, my neck is killing me.
At least you got to sleep.
For one of these.
Fraction.
Really? You think this is hard?
Extra step.
There's an extra step?
Well, no matter what, it's gonna be an even.
Yeah, and it's less than 0.
What's the leading term?
The leading.
Leading term.
Oh, it's 4.
2 plus,
X to the
X
fourth.
plus 1, X.
Oh, X to the 4th over 3.
Leading term is a third x to the 4th. That's all we care about.
The outside term.
It's the first term, that's the term with the highest power. Right? That's what the leading term is. So all we have to do is figure out the first term of that expansion. X to the 4th. Right? Because that leading the coefficient by Pascal's triangle for the first and last terms is always 1. If that was like a 3x in there, it'd be 3 to the 4th, x to the 4th, right? Because you have to raise that entire term to the 4th power. We don't care about the rest of the expansion. Again, why? Because this term is going to dominate the entire thing. Now you use that and you go, okay, which of the 4 cases does this satisfy? Even power.
A positive A,
Positive coefficient.
so it's just like the last one.
No, it's not. Last one was odd.
Oh, the other last one.
It's gonna be.
The other last one was degree 5, leading coefficient of -1
Number
and
6.
constant -4.
Oh, shit, no, that, okay. Oh, now I'm on the trolley.
Is it?
Are you sure you also weren't feeling under the weather this weekend?
Did great on the homework.
Might still be taking some of that medicine, and you didn't bring me any. my wife to go out and get me cough medicine, and she forgets the freaking cough medicine. And then she goes out and gets it, and it's freaking honey flavor, not raspberry. Just as soon as she brought that home, I was feeling better.
I use that chloroseptic menthol.
I actually like menthol.
Brings back such childhood memories.
Problem is, I have to be careful because if I do anything menthol, it gives me a strong urge to start smoking again.
Oh, yeah, I guess it would. Oh, I'm glad you stopped.
If I ever want my wife to leave me, I have to do a smoke. So I have an easy out of the marriage.
Leading coefficient is 1/3.
So is this gonna be the second, the,
It's gonna be the one that's like going down or up.
Oops, why did I do negative infinity? Goes up on both ends.
Because 1/3 is even?
No, the power is even,
Oh, yeah, that is even.
and the coefficient is positive. Right. I do have a method on how I memorize this. Even says that does the same thing on both ends. Positive up, negative down. Right, so if it's an even power, you know that the function behaves the same way on both ends. Coefficient tells you if it's up or down. Positive is up, negative is down, which makes sense. Odd, they do different. They behave differently on the ends. Positive is the same as x. So f decreases, x decreases, f increases as x increases. Negative, they do the opposites. So f decreases as x increases, and f increases as x decreases. That's how I always remembered it. Yes. The ends behave oppositely. Right, so if it's even, you know they're both either going to be infinity or negative infinity. If it's odd, you know you're going to have one infinity and one negative infinity. And then the coefficient tells you which it is. Do enough of these, like I said, and you have no problem. This will become second nature. So now I'm never going to be able to look at you the same way. Now every time I look at you, I'm going to think of take me. That's not going to ruin my whole semester. Maybe I'll have the final in class, and I'll just have that song. I'll just have that play sometime during the final exam. Just when she thinks I've forgotten,
No.
and then she won't be able to finish the final. Leading term. X what? Thought you said group. Sound like group.
either the new, the trailer for the new.
I've actually never seen it. I just like
Never
group.
seen Any
Hmm.
green galaxies.
I
But is
don't like Marvel movies, DC. I don't like any superhero movies.
I won't
They're
watch
stupid.
it. Used to watch it. It's so boring. It's so boring.
And
One exception, Deadpool. Deadpool's awesome.
Somehow.
So which case do we have? Odd power. So what's the behavior? You're not there yet.
They're both opposites.
No, it's gonna be F
F goes,
negative and
oh, sorry.
I don't know how to explain it right. You're writing the exact one thing.
Yeah.
Yeah.
All right, f goes to infinity as x goes to minus infinity. F goes to minus infinity as x goes to infinity. And this is why I really don't like this. As I said, these are technically limits. That's what that first one says, but that's calculus. Can I? I can. I mean, it's possible. It's possible for me to do it. One. Right, so I tried to pick problems in the homework that didn't use limits. And you would not believe how difficult that was, even though it was literally algebra.
This is the homework that's gonna be posted today.
Yes. Even though it's under algebra category, they were writing limits, which is calculus, which is really frustrating. It's like really generous for all of these. Leading term. I can't believe I didn't jumble any of these up to try and throw you off. So what is the case? Which one do we have?
F going into negative as yeah, it goes into I can't read my handwriting, I'm so sorry. I genuinely cannot read my handwriting, I'm so sorry.
Oh boy, I guess I'm looking forward to grading your test then. You know the rule, if I can't read it, I'm not grading it.
It's gonna be perfect for me though.
The infinities are gonna share signs in this one.
Right, f behaves the same as x. Odd power, positive coefficient. Coefficient is the coefficient of the leading term, the leading coefficient. Right, so what's the coefficient of x cubed? So that's what we look at. It's the leading term. And so what is the scenario? Which of the four do we have?
The first one,
It will be.
Which is what?
a positive degree even.
So what does the function do?
It's gonna be a parabola open. Or,
So what does that mean about f? What does f do?
oh, so it approaches it, the infinity for either direction. It approaches infinity for either.
Is there like a shorter way to say that? Or is it like,
Yeah, using limits.
oh,
Otherwise, no. This is it for now.
Couldn't just write F arrow infinity both ways? All right.
No, because then I'd argue, what do you mean both ways? Do you really know what you're talking about? I'd probably call you off and make you explain it. I have done that. I wasn't convinced you knew what you were talking about, and I thought you looked it up. I made you come into my office and explain it to me. I just realized I didn't read the instructions all the way, so I'll have to go back and do something, because we're missing one thing from the instructions. That's okay. I can always go back and fix it. What's the leading term? So what's the function behavior?
This one?
it's the one that goes down, basically.
Even, and it, yeah, it goes down.
Yeah.
You could just take the previous one, right?
So what's the
Stick-
behavior?
And stick,
F going into.
I can.
That's into negative infinity. And then F negative infinity as X. Positive
And there's your end behavior.
infinity.
You were thinking the power was odd.
B?
When it starts from the left, starts from the left to the right, like that, that's odd.
That shape is odd power. Parabolic is even
Oh,
power.
yeah.
All right, so there was one other thing in the instructions. We had to determine the maximum number of turning points. So a turning point is exactly as it sounds. It's where the graph turns. So it's points where the function switches from increasing to decreasing or decreasing to increasing. So there's a property of polynomials. Polynomials are continuous, smooth, and have a maximum number of turning points of the degree -1. So a 5th degree polynomial can turn a maximum of 4 times. A polynomial is n-1, the degree -1. Right, 5th degree can only turn 4 times, maximum. Notice it says maximum number. It doesn't tell you the exact number. Again, you need calculus for that. So what's the maximum of turning points for number 7?
2.
2.
The exponent -1.
8. 9.
2.
10. 2.
Sorry, I was looking at 11 at first.
11.
3.
12.
Okay.
Maximum number of turning points.
Hear that again?
Oh, that's a bummer. How much is it worth to you? I'm thinking $100 trillion.
Just take the biggest exponent -1.
Thank you.
So you're a lot nicer than me. Could have made a killing there. And if you can't pay, I just charge you my daily interest rate of 100%. Unless I'm in a bad mood, then it's a secondly rate. I'm a math major, so I'm good with numbers, so don't think I'm gonna forget either. Questions on the definition of a polynomial? And so we had leading term, leading coefficient, the constant term, degree, number of turning points, and end behavior.
So every time the exponent is even, is a parabola.
It's parabolic.
If
Well,
coefficient-
I want to be careful. When we're talking about power functions, yes. The polynomial itself may not be parabolic. Like some fourth degrees look like W's, which is not parabolic. But when you're talking about end behavior, yes. Even tells you, in terms of end behavior parabolic, odd tells you it's going to be S-shaped.
Even a negative graph, it's like, is it F going into negative infinity as X goes into negative infinity, and then it's F going into negative infinity as X goes into infinity?
Because even Powell tells you function behaves the same way on both ends. The point of taking notes if you can't read them. I mean, not understanding them is, different, because I did that in statistical physics. I would go back through my notes and not understand the goddamn thing that was going on. I just said, I wrote this down because it looked important, but I don't know what it means. But at least I could read it. Excellent. Say I'm still recovering, so we're going to call it early. That was just definitions of polynomials.
I'm gonna be able to do it.
That should be very easy, actually.
Right, I don't know what you're saying.
I think they're all easy. It's just name.
Fraction to the power of 37.
Right.
No, not bad. It's so close to you all.
Just turn around. It's something.
No, I didn't hear. I didn't realize how close I was. There's the whole planet. For real.
You're allowed to hit him back. I just can't be looking because I can't be a witness. If I have to be a witness to a crime, I do charge you.
That's awesome.
Oh yeah. If you assault someone in my class, I have to go to court and be a witness, and I charge you for that. That is assault, yes.
You're like 16. If she balled up her fist and like moved it at your face to make you flinch.
That's so something.
Yeah.
No, it's not.
Place someone in apprehension of bodily harm. Oh, yeah, absolutely.
It's legally, it's different.
It's still assault.
Intimidation is not illegal.
Oh, yes, it is.
Certain types of.
I'm an attorney.
Not illegal. Now, with
Yeah.
a gun, yes, that is.
No, placing someone in apprehension of immediate bodily harm is an assault. But you know what? We'll leave it alone.